Has a dog ever smelled your sweat samples? Our article we read is all about that. Our article is called Detection of SARS-CoV-2 by Canine Olfaction. And as the COVID virus continues to dominate our society, our economy cannot keep up with its rate of infection, effects, and prices of COVID tests, along with the absence of COVID tests. Hospitals have been operating at full capacity as the spread continues to increase with symptoms, along with the delayed turnaround rate of the COVID test. Scientists have been researching endlessly to find new alternatives to test for the virus and its variants. The biological question of this experiment is, can the COVID virus be detected in any other way than the current methods, which are expensive, invasive, and have slow results? Our hypothesis is dogs can detect the COVID virus when analyzing samples using traces of volatile organic compounds found in samples of patients' breaths, urine, and sweat. What technology did the experimenters use, and what were their methods? The independent variable was the status of the COVID test, as the results were switched to test the dogs on their accuracy. The canine training sessions were also another independent variable, as training sessions were changed by trying new combinations of the COVID test results. Our dependent variable was the accuracy of dogs sensing either positive or negative samples, and the control was the dogs used to sense the odors, a medium of the COVID sample, such as the sweat samples, and the negative COVID tests.
I'll be going over the methods of this study. In this study, it was made up of both humans and dogs. A human, like this. Humans were participants of the study. They underwent RT-PCR tests within 72 hours of the sample collection. This included subjects that were both asymptomatic and symptomatic to COVID, hospitalized but not in severe condition, and non-hospitalized individuals, but excluded those with a positive RT-PCR test 90 days prior to the collection samples. Individuals who were cases tested positive, while controls tested negative in the RT-PCR test. In total, 584 samples were collected, 141 positive and 443 negative. Meanwhile, canine scent detection training took place at a Hawaii training campus for dogs. 3 Labradors and 1 Golden Retriever, ages spanned between 1 and 5, were used in the study. To train the dogs, double-blind studies were conducted with 5 scent detection boxes that were baited with fresh sweat samples from individuals either positive or negative with COVID. Correct guesses were rewarded with a treat or the response of a clicker. The sample handler was the only person who was unblinded during the testing phase of the test sample trials. Samples were disposed of immediately after the session was finished. The total training time for each dog averaged around 20 hours, taking place 1 to 2 hours per day, 3 days a week, for about 6 weeks.
The researchers calculated the dog's accuracy using sensitivity and specificity. Sensitivity is the frequency of accurate positive alerts, while specificity is the frequency of accurate negative alerts. The 3 dogs had a sensitivity of 98% and a specificity of 92%. The researchers also calculated the positive and negative predictive values. Positive predictive values were 80% and negative predictive values were 99%. In the implementation phase in a hospital setting, the dog test had a sensitivity of 96.4% and a specificity of 100%. The researchers interpreted that the canines used were able to sense the volatile organic compound residing in the presence of the COVID-19 virus, which allows the canines to detect the positive tests from the negative tests.
So what biological conclusions can we draw from this experiment/paper? Dogs have extremely sensitive and highly defined senses, which are more powerful than that of humans. Canine scent detection is gaining attention as an effective and reliable method for identifying infections, viruses, and diseases. As a matter of fact, dogs' olfactory acuity is more than 100,000 times stronger than that of humans, with the ability to detect odors in parts per trillion. So what does this mean? Through the smelling of saliva or even sweat, these canines have the biological makeup and tool that is needed to detect the SARS-CoV-2 virus within the body, as long as they are given samples that come from within the individual's body itself. This is awesome because now there can be medical detection dogs trained using their natural senses to help people from all around the world. Medical detection dogs are being utilized in olfactory research of diseases such as cancer, diabetes, and malaria. Growing researches have shown that dogs can detect bacterial and viral infections with high rates of precision and accuracy. This is great because with the ever-growing variants of COVID-19 and the limitation of testing available in scarcely resourced countries, there is a new trustworthy source of testing on the rise by the use of these canine senses to detect the virus, especially within those who are asymptomatic or early within their stages.
Futures ideas. What is next? I think they will be able to provide these medical detection dogs at public places such as schools, businesses, and hospitals, as seen in the study, to allow for quicker, safer, and more accurate methods such as the PCR. With recent technological advances, electrical noses may be developed and mass-produced to help screen and provide early detection of SARS-CoV-2 and other diseases. The dog's high accuracy rate at detecting asymptomatic individuals suggests that they will be able to identify those who are pre-symptomatic. Also, the trainers can allow the dogs to be introduced to new variants, and such as monkeypox and other variants that are now developing. Going forward, medical detection dogs may prove to be a valuable ally by providing rapid screening of emerging diseases and helping control the spread of future pandemics.